and it's reads this way: the voltage and current in the primary coil of a transformer are 200 volts and 2 ampere respectively. If the transformer is used to light 10, 12 volts, 30 watts bulbs, calculate its efficiency. And you have these options: option A, 100%, option B, 90%, option C, 75%, and option D, 50%. How do you solve this? Especially if you have this kind of question in an exam situation. What do you do? Very simple. Create a picture of a transformer, right? Doing all this. So let's look at diagram first. Maybe I always like to put something in a diagram form. If I have something like this, watch what I'm doing now. If I have something like this to represent maybe a rectangular core transformer, right? Alright, okay. And then this is the primary section, this is the secondary section. And I have coil this way, it comes again. I have this as my primary coil at this point, okay? And so on. And then I have this. That means whatever is happening here is the primary section. That's the first thing to know. Whatever is happening here is happening at the primary section of the transformer. Take notes, okay? Also, whatever is happening here is happening at the secondary section of the transformer. So if we have this way, I'm going to make this smaller it's a kind of step-down transformer. How would you know a step-down transformer? By the number of coils, okay, at the secondary section, right? So this is the secondary section of this transformer, right? Secondary section of this transformer. Primary section, secondary section of the transformer. You can assume this to be a step-down transformer. It is a step-down transformer if the number of coils at the secondary section is less than the number of turns of coils at the primary section. I repeat, if the number of coils here is less than a number than the number of coils here, or turns here in primary section, that means the transformer is a step-down transformer. I think that is very simple and well explained. So with this, the question is this: we are expected to calculate the efficiency of this transformer, especially when we have the primary voltage, VP is giving us 200 volts. That's this. IP, that is primary current, IP, is giving us 2 amps. I don't want to stop this with information. Let's spread out now. VP, we start with our solution, all right? VP, that's the primary voltage, is giving us 200 volts. That's the first thing. And the second is that the primary current IP is giving us 2 amps or 2 amperes, so to say. All right? Okay, so that's the beauty of it. You have a diagram of a transformer that is functioning this way, supplying this amount of energy to certain amount of bulbs. Okay? We want to find efficiency. The efficiency of this transformer, right? So let's see. Now the next thing is that if the transformer is used to light up 10 bulbs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bulbs, each rated 30 watts. You can see the power is already specified. But there is something here. There is something we don't have here. We don't have secondary voltage, all right? Okay, we don't have secondary current. Okay, some persons will think this is okay, and then we need to specify the appropriate formula to use to find the efficiency here. And that will be the secondary voltage Vx over primary voltage Vp is equal to secondary current Ix over what? The primary current Ip. That is it. If we have this, we now know the basic formula to use in solving problems that have to do with transformers, okay? But there is a question here. The question is the efficiency. So we can find efficiency as power output over power input, right? Times 100%. That's what we're supposed to do. I repeat, efficiency can be found as power output, okay, over power input, all right? Output PUT and then input PIIPUT times 100%. So what is the power output and what is the power input? That's the question, right? So we begin from there. Power output over power input. So to say, what we need to do is very simple. Look at the power is already identified as the one being supplied to 10 12 volts bulbs, right? So we already know that. What we need to do is this power times 10. That's the power, total power output. So we may not have anything to do with this. We will now concentrate on this. Because we're talking about power output over power input. So what do? We go back. We come to this point and say that our efficiency, now, let me cross this to avoid mixing things up, okay? All right? Efficiency is our power output. Where is our power output? Power output is 30 for each bulb times 10. All right? This is the voltage of the individual bulbs, no problem, but this represents the power each bulb gives. And there are how many? There are 10 in number. This number times 10. So we have power output, all right, over power input, all right, power inputs, P, capital P, should be times, look at it, times 100%, so we substitute. Power output for efficiency, watch out, power output is this 30 times 10, all over power input, this is input, all over power input. Let's see, our power input is 200 volts, we must find that because power originally is P is equal to IV. If you recall this, the power is given as IV, then you will not know that we have voltage, that is V, we have current 2 amps, that is I. It means that for power input we have 200, right, times 2. That's for this, from this section. All right? Good. Having done that, the next thing we need to do is to simplify. But something is missing. Times 100%, times 100%. That is it. So let's quickly do that. Our efficiency formula remains. This times this is 300, right? And then this times this is 400 times 100%. Very simple. What are we saying? We are almost there. We're almost there. And by the time we simplify further by cancelling out where necessary and multiplying where necessary or dividing where necessary, we will have that cancel 0 here, we cancel 0 here. We are left with just percentage sign. And the next thing is our efficiency is 300 percent sign is still there, all over 4. And by the time, look at this. Let's go simply do this in a very simple way. If we say 2 divide 4 is 2, right? 2 divide 300 is 150. Good. That makes sense. And we go again. 2 divide itself, 2 divide 150 is 75. Do you see that? Can you see that? Yes, it's 75. Therefore, efficiency is equal to 75%. Let's check. It's 75%. Let's check. From the options given, A 100%, not it, because it doesn't correspond with this.